Alright, well now we're on the last review pack that I have for you guys. Again, I want to encourage you guys to maybe watch me do part A of these problems and then try to do the remaining parts, like for instance in this problem B and C, on your own. Okay, so I want to kind of start out just with a little reminder with how these guys work. So what I'm going to do first is say that, alright, well, if I just in general have cosecant of some angle, I don't really care what it is, and notice how it's not the inverse, I'm just talking about regular old cosecant, equals A. We know that's the same exact thing as saying this is equal to 1 over the sine of theta. So the cosecant of theta equals something, some value, we really don't care what it is right now. But that's the same thing as saying 1 over the sine of the same angle equals that, because again, cosecant and sine are reciprocal functions. Okay. So what I'm going to do is I'm going to take this part here and just remind us how we can rewrite this. A little trick, I'm going to switch where the A and the sine of theta are. It's a little algebra trick just by simply multiplying the sine on both sides, then dividing by A. But again, it's just a little trick. So I'm going to write the sine of theta is equal to 1 over A. Again, just by switching those. And now I can say, okay, well, the whole time we were worried about figuring out what theta is, anytime we're asked to find an inverse, they're asking for what is the angle. So this is the same thing as saying theta is equal to sine inverse over 1A. So that's like really like the nitty gritty about it, but really all I'm going to do in this problem is say, okay, the sine inverse of what we have in parentheses here, it's just going to be the reciprocal of that. So it's just really going to be negative 1 over square root of 2. And then I'm going to say, well, I'm going to simplify this because it looks like something in a unit circle, but not quite there yet. Sine inverse of this, if we rationalize the denominator, is negative square root of 2 over 2. Well, then, hey, look at that. Sine inverse equals negative square root of 2 over 2. We talked about in the first review packet that the inverse for sine only exists in the first and fourth quadrant. So what angle measure gives us a y value, because again that's what sine means. So again, what angle measure gives the y value of this? Well, our answer is negative 45 degrees, or equivalently, negative pi over 4. I'll go a little bit faster with these. The secant, the inverse secant, is the same thing as saying the cosine inverse of the reciprocal of this fraction right here, which is 3 over 2 square root of 3. If we rationalize this denominator, the reason I'm doing that again is so that I find something that looks like it on the unit circle, because a lot of these problems give you exact values. Rationalizing the denominator gives us 3 square roots of 3 over 6, and then we see that, wait a second, the 3 and the 6 cancel out. 3 divided by 6 is just 1/2, so we get the cosine inverse of square roots of 3 over 2. Cosine inverse only exists in the first and second quadrant, so we have to pick a value, an angle value that gives us an x value of square root of 3 over 2 in one of those quadrants. Well, if we were in the left quadrant or the second quadrant, that would be negative in the first quadrant here, that's going to be the positive one. The angle or the answer would be 30 degrees, or equivalently pi over 6. And the last one, cotangent inverse. Okay, I'm going to go a little bit even faster on this one. I'm going to say the tan inverse of the reciprocal of this guy. Simplify this time. I'm just going to skip right to the simplification step. Negative square root of 3. So I encourage you to do a little scrap work off to the side and see if you can come up with that simplified answer there that I got. Again, tangent, the inverse of tangent only exists in the first and fourth quadrant. So our answer that makes sense for this problem is negative 60 degrees, or equivalently negative pi over 3. Alright, so we have all 3 of our answers, or I guess actually 6 of our answers. So let me clear this and then we'll do number 33, or I'm sorry, number 2, which is 33 from the text. Okay, so a lot of stuff going on here, but kind of switching gears. Actually trying to figure out a real world problem this time. We're trying to figure out what the height of this taller building is. So I'm first going to start off by labeling a few things. First of all, I know that if this is 30 over here, that this also has to be 30. We're going to assume that this is a level street and it's directly across, so this point from here to here is also going to be 30 because it's here. Okay. The other thing I'm going to do is say I'm going to call this x. So that's the distance from the top of the building to here. So our final answer is going to be x plus 30. So let's figure out what x is, and then we just add 30 to it, and we'll have our final answer. So I'll come back to this later and put our answer here. Well, in order to find x, we need to find something in this bottom triangle. So what I'm going to do is call this line here y, and I'm going to figure out what y is, and then I can use y to figure out what x is. So I'm going to set up an equation. It's a couple steps in this problem. So to figure out what y is, I'm going to write the tangent of 20 degrees is equal to the opposite over adjacent. So 30 over y. Well, if we solve this equation, I'll show a couple steps. Multiply both sides by y because we want to clear the fraction. We get y times the tangent of 20 degrees equals 30. If we divide by tangent of 20 on both sides, we get y equals 30 divided by tangent of 20. So that's going to give us y is equal to 82.4 feet. I'm not going to circle that because that's not our final answer. We still need to figure out what x is. So I'm going to write, now I'm going to use the y and the 50 degrees in the top triangle. I'm going to say now tangent of 50 is equal to x divided by y. Well, we know what the y value is, 82.4 feet. I want to multiply both sides by 82.4. Now give me my x value. X ends up equaling 98.2 feet. So my final answer, all said and done, is going to be 98.2 plus 30, which is 128.2 feet. And sorry, that's a little hard to see. Our final answer, once again, is 128.2 feet. And the last one I'll take a look at in this video is number 3. Just bear with me. Okay. So once again, switching gears, because that's kind of what the final does. It summarizes a little bit of everything we've done. Number 3 says to find the polar coordinates. So this was actually on our very last exam. Find the polar coordinates that represent the Cartesian or rectangular coordinates for these 2 points here. So it says just find one pair of coordinates. Don't ask for both. So what I want to do in order to figure out what r is use that formula we've always used. R squared equals x squared plus y squared. And if I substitute my values in, negative 4 squared is 16, plus 2 squared is 4. You get 20. Square root of 20 is approximately 4.47. But sometimes I'll give exact answers, so remember that this is just the square root of 4 times the square root of 5, which is just 2 square roots of 5. Okay. So then I need to figure out what theta is, because again, polar coordinates means r and a theta, a radius, how far away from the center, and an angle. So theta is equal to the tan inverse of y divided by x so if I substitute my values in, I'm not going to use the negative values that I'm given. I'm just going to use the positive values. So what I mean by that is I'm going to write 2 divided by 4 inside my parentheses. So tan inverse of 2 divided by 4 is equal to tangent of 1/2 which gives us approximately 150 degrees. 53 degrees, sorry. So our final answer for part A is, I like to leave it in exact form. Typically that's how multiple choice will be presented, so I'll use the exact R value, and this gave us an approximate angle value, 153.4 degrees. Okay? So again, pause the video, see if you can do part B by yourself. Once you've got an answer, come back and check it. So in order to figure out what R is, again, I'm going to take R squared is equal to negative 2 squared. Negative 2 squared is just positive 4. I'll write 4. 0.9 squared is 0.81. So we get 4 plus 4.81. Square root of that guy, and we have 2.19. Not going to have any exact values here. I mean, this is exact. We didn't round it at all, but we don't have anything nice and clean like this guy over here. We do have a decimal this time. theta is equal to tan inverse of y over x. So 0.9 divided by 2. Remember, only use the positive values when you're figuring out this angle. And when we get our answer, we get 24.2 degrees. But remember that this point right here is in quadrant 2. So quadrant 2 means that we have to subtract the 24.2 degrees from 180. So we actually get a final answer for theta of 155.8 degrees. So our answer is 2.19, 155.8 degrees. So I'm just realizing now that I kind of forgot to explain that part in part A. So when I actually did this calculation, I got 26.6 degrees. But remember, the point up here is in quadrant 2. So just like I got done explaining in part B, we need to take the angle that we get, 26.6 degrees in this situation, and subtract it from 180 to get our actual theta value. So just think about what quadrant it's in and think about if your angle makes sense or not for that quadrant.